the death of a cyclone. And a cyclone will begin to die once he develops that occluded front. Oh my goodness, that seems important to the life of a cyclone if we're talking about how it dies. So let's spend some time thinking about what's going on along an occluded front. What I want to do is I want to draw some cross sections here. I want to draw a map, kind of like this one that's up over here. So here's my map. I want to have a cyclone, a cold front. Sorry, there's a map there. That's on the floor. Where'd my red pen go? You won't believe how many of these red and blue pens those go on at my house. It's a crazy big blue. All right. You got a cold front, you got a warm front, and you got an occluded front. Hey, how do I know it's an occluded front? Well, if we draw it, just like we drew cold fronts as being a blue line with blue triangular teeth pointing the way the cold air was moving, and we drew a warm front as a red line with red semicircular teeth pointing the way the warm air was moving, an occluded front has triangles and half circles. I didn't draw them very well, but they're better drawn over here. Let me go back up for a second. See how there's triangles and there's half circles? And they're both pointing the way the cold air was moving. How's that different from a stationary front? Stationary fronts had the triangles and the half circles on opposite sides of the line. Now they're on the same side of the line. So we've got an occluded front and a cold front and a warm front. They meet at the triple point, which is not at the center of the cyclone. Now what I want to do is I want to make some cross sections through there. I want to draw a cross section like if you were driving from location A across here to station B. Let's think about what the atmosphere looks like as you go along that slice through that cyclone. So what I'm going to do here, here's the ground, here's A, and here's B. Now when you're at location A, you are in the cold air mass. You are behind the cold front. And if you think back to what a cold front looked like when we talked about fronts on Thursday, you know that the cold front is actually a three-dimensional surface that slopes back with respect to height. It slopes back over the cold air. It's a pretty steep leading edge that is plowing that warm air out of the way. So we have some cold air here, and the leading edge of it is the cold front. So maybe this is continental polar air or something like that. And then out ahead of the cold front, we're going to meet. So here we are driving from A to B. When we hit the cold front at the surface, now we are in some maritime tropical air. Let's give you another important name. This warm air mass that is between the cold front and the warm front is called, here's a nice vocabulary word, the warm sector. The warm sector is that sort of triangular shaped area of the warm air mass in a mid-latitude cyclone. It is the area between the cold front and the warm front. Nice to have names for things like this. So as we drive from A to B, we started off with a cold air mass. We hit the cold front. Now we are in the warm sector, the warm air mass. And at some point we will hit the warm front. Now remember what the warm front looks like? It's sloped. And it's sloped quite gently because most of the, let's remember this power vocabulary word, most of the warm air is not actually moving the warm front, it's mostly just overrunning the warm front. And then out ahead of the warm front, you're back in another cold air mass, maybe continental polar again, or maybe maritime polar, or something like that. So if you were driving from A to B, you'd start off in the cold air mass, you'd hit the cold front at the surface, you'd drive across the warm sector, and then you hit the warm front at the surface, and now you're back in another cold air mass. Right? Can you picture this one here? This we could have probably done on Thursday. Now, let's make the same kind of thing, except let's make a slice a little farther to the north. How about a slice that goes right through the triple point? So now we're going to drive from point C to point D. Okay, so I'll make myself another little cross section down here at the surface. Here's point C and here's point D. How do I drive from point A to point C to point D? As I drive from if I'm at point C, I'm clearly in the cold air mass. I'm way behind the cold front. I'm back here in maybe some continental polar air, something like that. And I drive along and I drive along, and at some point I hit that triple point. Here's that leading edge of that cold front. See how the air mass has pushed farther to the east? And it has caught up with the warm front. So this is maybe maritime polar or something like that air mass underneath here. And up here above the ground, here's where your maritime tropical air is. Can you see how the diagram I drew here and the diagram I drew here are related? All we've done is we've pushed this cold air mass farther to the east, and it has caught up with the warm air mass. Caught up with the warm front. There's still a warm air mass, it just isn't at the ground anymore. It got completely lifted up off the ground. And it wasn't really all that hard to lift because it was warm, it was light, it was not very dense. Right? We have lifted this whole warm air mass right up off the ground and caught the cold front up with the warm front. So right here at the triple point, we've caught the cold front and the warm front together. We've caught them up with each other. In fact, if we went even a little farther north, and we cut across the occluded front itself, from like point E to point F, we could make even one more cross section, going from E to F. Now if we're over here in point E, we're clearly on the cold side, and we drive and we catch up with that front, which has actually pushed even farther to the east and has lifted that warm front off the ground. So we're seeing some cold air mass over here on this side when we're over by the E, and when we get over here on the F, on the side ahead of it, east of the occluded front, we're in another cold air mass, and if there's any warm air left at all, it's been lifted way up off the ground. It's not down here at the ground at all anymore. Can you see how these three diagrams are connected? We just kept pushing the cold front farther and farther to the east until it caught up with the warm front, and then actually lifted the warm front up off the ground. And in fact, there are much nicer than I can draw diagrams like this up on blue line and in your textbook that show the same picture. We used to have these puppets. They weren't like puppets like Muppets. They were puppets like this one was this was a cold air mass on this end, and this was a warm air mass on this end, and we'd slide them up underneath each other or whatever. And then at some point we decided that was kind of insulting to have these puppets here. Can you picture though how the air masses slide under it? The cold air mass is catching up with the warm air mass and then sliding underneath it? Yeah, I don't think you need a puppet to show that anymore, okay? I think you guys can kind of visualize that. So there's still, once we get up here to the triple point, from there on to the north, notice that front is kind of a weird front. Fronts that we've had in the past, like cold fronts and warm fronts and stationary fronts, they separated air masses that were very different. You got warm air on one side and cold air on the other. Or dry air on one side and moist air on the other. But look at this weird occluded front. I mean, an occluded front has got cold air on one side and cold air on the other. Not really much of a front, is he? I mean, the whole business of fronts was that they were supposed to be separating air masses that were different. This isn't all that different. Now, if we think back to, say, the thermal wind relationship, oh my God, Dr. Schragi mentioned the thermal wind relationship again. I was hoping he'd forget about that. I forgot about it. I didn't want to think about it over spring break. No, you have to think about it. The thermal wind relationship was telling us that, if you remember, that when you had a polar front, whether it was a cold front, warm front, or stationary front, you had a jet stream sitting on top of it. When you had that jet stream up on top of there, well, we don't